Hello and welcome to the relearning for arc lengths. Please make sure you put the date at the top as well as your name. Even though the name wasn't put on here, please put your name at the top so that I can give you credit for your relearning. Okay, an arc length. So we have to have a definition so we know what we're talking about. So we're talking about this section between the 2 points. It's really a line, but it's curved. So we're going to call it part of a circle defined by 2 points. Think pizza crust. So we're looking at pizza crust. So we're looking at if we wanted to, we could actually probably force that curved line to be straight. So we're looking at just that curved line that's in here. In the second part, we're looking at how is the arc length different from the measure. We talk a lot about in class about the measure. We're looking at the difference between the two. So this over here in the degrees is the measure. This is the measure where we're going to have our answer in degrees. And we're going to be looking a lot at the central angle. And if this is the central angle, then the angle measure, the vertex is in the center and the measure is exactly the same. So this is 75 degrees, which means that if we were to go around our circle, starting here and going all the way around, we would travel 360 degrees. We're talking about traveling only 75 degrees of that whole way around, only 75 degrees. So the distance, if you can read it in here, it says inches, feet, centimeter, etc. Anything but degrees. So we're looking at, it's not always very practical to say that I traveled 75 degrees. So what we're looking at in here is we're going to see if we can travel 6 inches or 45 meters or we're traveling 450 miles. So what type of this arc, if we were to measure what it would be? In this case, it's based off from our radius. In this case, it would be inches. And we can solve it. We're going to solve it by proportion. So the distance, when it says in here length, this is length. This length right here in distance is considered anything but degrees. Measure means that we're talking about it over here, but we are going to have to use the measure in order to find the length. And number 3 in here, what is the formula for finding the arc length? Right here. This is the one we're looking at in here. This is what we're looking at. This tells us again that the arc length and the central angle, this should be arc measure, are the same. The arc measure are the same. But this is the formula we're looking at. It's the central angle, which is in degrees, over 360, which is degrees, is the arc length is equal to, and this is our circumference. So that's our formula for circumference. And you can see that it depends on the radius. Here's the radius, so we need that part. Okay, a couple things before we get to some practice problems in here. What's the difference between the estimated length and the exact length? Estimated length and exact length. The exact length needs pi in the answer. If you do not have pi in your answer for the exact length, you are estimating and you are shortening pi quite a bit up. So when we use 3.14, it's not exactly pi. Pi is much more than that, but we're using it for practical uses, which means that it's just estimated. All right, there's times where we're going to need to go back and forth from the estimated length to the exact length. And you can do it one of two ways. You can do the problem twice. Okay, and then when we do the problem twice, we use the formula twice. That is an acceptable way to be able to do this. We can go back in here and just leave pi out when we solve for it. Or we can switch back and forth. So if we are given something, a number, times pi, it'll give us our estimated length. So what do I mean by that? So if we leave it like a number times pi, that indicates an exact length. But if we need the estimated length, we can substitute 3.14 in here for pi and times it by the number that's in front of it, and that'll give us our estimated length. If we're given the estimated length, we can divide by 3.14 and we can get the number in front, which helps us put together the exact length. All right, let's look at some problems so we can put this together. So looking at in here, we have the estimated length of arc BC. So this is the one we're looking for right here, BC, arc BC. We have our formula already written down. So let's plug in our values. We know that the central angle is 75 degrees, 75 degrees. We also know that this arc length is 75 degrees, but we're going to change the units. We know we need to have it over the total. The total is 360 degrees. And from your chemistry class, you can see that you can cancel the degrees, cancel out. We're looking for the arc length, so we're going to just call that x. And then we're going to put in our circumference, which is 2 times pi, and then our radius is our 10. Our radius is our 10. We are looking for the estimated length, which means that we are going to use 3.144 pi. We're going to use 3.144 pi. So let's simplify this 2 pi times 10 down. I'm going to put this over here. 75 over 360 equals x over 2 times 3.14 times 10 gives us 62.8. 2 times 3.14 times 10 gives us 62.8. And now we have a proportion. We should be really good at these proportions. We've been using them for the similar triangles. So we're going to say, I'm going to take this right up here, is 360x. 300 times whatever this is equals 75 times 62.8. So we're just cross multiplying there. And now we're off to the races. We can do these in our sleep. 360 times x equals 75 times 62.8, which is 4,710. Divide both sides by 360. And voila, our x is equal to 13.08. And because we need the unit, it is inches. It is inches. So we can redo the problem again if we need to, or we can say that there is a number times pi for our exact length will equal our arc length, 13.08. So this is our estimated amount. Our exact is a number times pi equals 13.08. Divide both sides by pi. We can figure out what that number is in the beginning. That number is equal to, and we're going to use our 3.14 for pi. 13.08 divided by 3.14. We put that together, we'll get 4.17. So what does that mean? That means that the number in front of here, so the exact is equal to 4.17 pi inches. So we just plug that right back in here, and that's 4.17 pi inches. Looking at the arc length here, we're looking for this section, and this is the one we're looking at. Now, don't be fooled because the B in there, we're just looking at the two endpoints, and again, it's a minor arc. So putting in here, we have our 135 divided by 360 is equal to our x over 2 pi times our radius, which is 3. So 135 divided by 360 is equal to x over 6 pi, which is 6 times 3.14 gives us 18.84. Cross multiply. 360x equals 135 times 18.84. Figure that out. 360x, multiply that out. That's 2,543.4. Divide by 360. X equals 17.07 inches. Now, if it doesn't say that we want exact or we want estimate, you can do what you wish. I prefer to do the estimate, but you can do however you want from there. This one specifically says that we need the exact. And it says that we are looking at a radius of 9 feet. So you have 60 over 360 is equal to x over 2 pi and then our 9. 60 over 360 equals x over 18 pi. Now I'm not going to multiply the 18 times pi because I want the pi in the answer. Cross multiply. 360x equals 60 times 18 pi. 360x equals 1080 pi. Divide both sides by 360. X equals 3 pi. And our units are feet. If we wanted our arc length, PQ, right here, is 60 degrees or 3 pi feet. 3 pi feet. Okay, so that is doing arc length.